What is a quantum observable for superposition? Imagine trying to catch a glimpse of a shadow that flickers between two places at once. That's similar to what happens in quantum physics with superposition. Now, to understand what we can measure in such a strange state, we need to talk about quantum observables. Think of an observable as a special tool or device that tells us something about a quantum system, like where a particle is or how fast it's moving. These tools are represented mathematically by operators, which are like functions that act on the quantum state. When a quantum system is in superposition, it exists in multiple states at the same time, like a coin spinning so fast you can't tell if it's heads or tails. The observable helps us figure out what the possible outcomes are when we measure that system. It has what are called eigenstates, which are specific states that give definite measurement results. When we measure, the superposition collapses into one of these eigenstates, and we get a specific value. The chance of ending up with a particular outcome depends on how much of each eigenstate is in the superposition, kind of like how mixing different colors creates new shades. For example, if a qubit is in an equal mix of 0 and 1 states, there's a 50-50 chance of measuring it as 0 or 1. The observable acts like a ruler or a gauge that reveals the possible results and their probabilities. It doesn't measure the superposition directly but, instead, shows us one of the possible states it can be in after measurement. This is key in quantum technology because qubits use superposition to hold multiple pieces of information at once. When we measure a qubit, the observable collapses the superposition into a single, definite state, which gives us the classical data we need. Think of it as a way to peek into the quantum world and get a snapshot of what the system is doing. So, in simple terms, a quantum observable is the measurement tool that tells us the possible outcomes of a quantum state, especially when that state is in superposition. It's what allows us to connect the strange quantum realm with the familiar classical world by giving us measurable results. Understanding this concept is fundamental because it explains how quantum computers can process many possibilities at once and then read out a specific answer through measurement.